Okay, rules for dimension values. Good hand lettering, that would be the same as text in CAD. Good hand lettering is important for dimension values on a sketch. The shop produces according to the directions on the drawing, so to save time and prevent costly mistakes, make all lettering perfectly legible. Again, this is for hand lettering. Your AutoCAD should be taking care of that, okay, with your text. Make all decimal points bold, allowing ample space. When the metric dimension is a whole number, do not show either a decimal point or a zero. When the metric dimension is less than 1 millimeter, a zero precedes the decimal point. When the decimal inch dimension is used in a drawing, a zero is not used before the decimal point of value less than 1. So in that little ribbon there in the middle, there's examples of how to write out your text or lettering on a CAD drawing or on a drawing period. Dual dimensioning. Basically, dual dimension is a combination of metric and decimal inch dimensions, okay? And there's examples on how to write those out, how you would draw a dimension line and put the text in. That one right in the middle, that top one dimension line there is 31.318. That's millimeters, that's the metric. And down below in the parentheses, they've got 1.233, and that's your inch. So you'd have metric on top and an inch in the bottom with enclosed in little parentheses. Symbols. There's a lot of symbols in drafting in CAD, and whether it's hand drawing or CAD drawings. Starting up in the upper left there, you got going across to the right, you have a counterbore, you have spot face, you have countersink, you have depth, you have reference. On the middle line, starting from the left to the right, you have arc length, slope, dimension origin, conical taper. The bottom left is square. Places are times by. You might see that on your drawings where you have you might have 4 holes in a part. They're all the same size, so you'd only give one dimension and say times 4. Okay. Radius, spherical radius, and spherical diameter. Some more do's and don'ts. Placing and showing dimensions legibly. Rules for placement of dimensions help you dimension your drawings so that they are clear and readable. So on the left there in the top, A and B, you got A is the good and B is the poor. The biggest thing to take away from the good is that they staggered the dimensions. Okay. So if all your dimensions lined up like in B there, you'd want to stagger them like they do on the left-hand side there in A. Down below in those rectangles, they're dimensioning those. On the left is the good. You got your smaller dimensions on the inside of the larger dimensions. On the right-hand side, you have a bunch of dimensions that are inside the part, and that's not good. That's very confusing. Okay. Going to the right-hand side, upper right, you have some best practice. You got an OK and you got an O. We saw this in our section view chapter, so don't do the one on C. We don't like C. We like B. We really like A, okay? And then when you have limited space, sometimes you're going to put your dimensions, especially your arrowheads and your dimension lines outside the extension lines like in A. or you could have it like B or C or D. You have those options. Placing and showing dimensions legibly continue. So here's some continuation of how to put dimensions in. On the upper left there, you have two parts. One is a section. They're the same part. One's a section and one's not. And the one on the right is not a section drawing, right? It's a regular drawing. And they're putting dimensions to hidden lines. That is a big no-no. You do not dimension hidden lines. So to be able to show that and be able to dimension that, they may put that in a section view on the left, and then they could put the dimensions in. Down below in the middle, you have a 3-view drawing. It says good, so everything looks like it's supposed to. They followed the rules, okay? But on the right there in B, they didn't follow the rules, and everything is not where it's supposed to be. They look like one of the things you want to do when you're dimensioning, you want to dimension a feature. And in the front view, you have, what is that? Is that 54? You put that from the bottom up to the center, and then you show a big radius there, a radius of 34. That's the outside arc. And then you have a diameter of 22. That's the small hole. Well, over in the right, in that B, they put the R34 in the top view, which you can't see the arc. You just assume that it's an arc. They put the location at 54 in the right side view. Again, you can assume it's an arc, but it's you can't say for sure. And then they put the size of the hole in the top view, and they're dimensioning basically to hidden lines. So that's not good. So we want to be clear. We don't want anybody questioning what's going on in their drawings. Okay, all necessary dimensions must be shown, but do not give unnecessary or superfluous. I'll get that word out in a minute. Dimensions. Okay. Okay. What they're really talking about here is you want to give all the dimensions that is necessary to make a part, but you do not want to duplicate or put dimensions on there that will confuse the reader. So you got to be really careful about over dimensioning a part. Okay. For example, if you look over in that on the upper far left, you got a three view drawing, and you notice they've got two depth dimensions of 12. You only need one. Either location's okay, but you need to get rid of one of them, okay? Because there might be a time where somebody comes along and makes a change to that drawing, and they make, say, the side view, they make it 14, and they don't change the top view depth of 12. So therefore, the reader, depending on which view he looks at, is how he's going to make it, he or she's going to make that part. In the middle there, B, you got two dimensions. The one with the horizontal dimension, which is a 0.62. You already know the overall dimension, and so if you take 0.62 on the right there, and then 1.62 in the middle, and you leave that 0.62 on the left out. You leave it out because you don't want to lock that the reader into thinking that's something else, or 0.62. Again, that could be a case where somebody comes in later and does a revision and changes one of those dimensions, and you mess everything up. Okay, so don't try to lock somebody in with a dimension like on the top, in the vertical there. You have 0.62, 0.62, and on the left you have an overall dimension 1.24. So we don't want to lock that reader in. We're going to make them believe that that's supposed to be symmetrical right there. Plus, it has something to do with tolerancing. If you got you have your tolerancing usually applies the same as the overall dimension to two of the smaller dimensions, and if you start adding those up, you can mess up your tolerancing too. So be careful about that. Okay. And C, on the right hand side, you have 12.7 and 60 degrees. You either put 12.7 or put 60 degrees, whichever. I'd take out the 12.7 myself. You don't need both. Okay. I'm going to stop there for a minute. We're running a little bit long on this segment.